This is WinnerMicro W806 development board. This one has 1 megabyte of flash and 288 kilobyte of RAM. Compared to the previous development board, even though the price is cheaper, this one holds more flash and more RAM. However, the development environment for this board is not very friendly to normal user. If you run on the embedded DOS, then the development process will be very similar to this board. Micro USB here talk to this chip through the CH340, which converts the USB to this serial port to this chip. I have ported the embedded DOS to this board now. So this is a reset. If we reset it, this one will say this CPU is WinnerMicro W806. And if we type here hello or help, it will tell you what command is available. Let's say chip info. It will display the CPU ID and the free memory and flash address frequency. The CPU ID here is not very consistent for some reason. I use the provided API call, but the rest information are accurate and important for us to judge if we have memory leak or not. So here we already have some files on the flash. Let's do a format command. Compared to the other chip, this flash is very fast. Now we can take a look. We have about 932 kilobyte of flash. And the rest of the flash are used by the embedded DOS itself as well as the chip itself. So the first application we are going to make is hello world. So make hello. For the application to be copied to the flash, you have to type the make command. You cannot direct copy command. Copy command will not properly generate the proper table for the application to run. So let's make a blink. This board has 3 LEDs. For the blink, we only blink in the first LED because the same code will run on the other boards, and they don't have 3 LEDs. So let's type the blink without any parameter. It will generate an LED on-off pattern at the 500 milliseconds interval. So half second on and half second off. So half second on and half second off. So any key will exit. So now I'm going to blink 200, which is 200 millisecond on and 200 millisecond off. It's faster. Flash 5 flashes per second. So blink 1 second on and 1 second off. So half hertz. So next demo we are going to do, which we already did for the other board, is debug. So we are going to generate debug code, directory debug, and it will monitor the RAM here. So display flash 0801 C000. This is the directory of this flash, and we can see we have hello.com and blink.com and debug.com here, and the real content of the hello.com is at CD0801 C400, and you can see the format is bin format, binary, and then the hello world. The second one is the blink. So last one, I'm going to show a demo for the LCD display. First make a LCD demo. So let's type LCD demo. Well, say, well, no, it doesn't work because the LCD demo is just a demo code is hardware independent demo code. So it does not know if which display is it. So I'm going to make the driver SSD1308.6. So now let's install the driver SSD1306 and driver installed, and let's run the demo, LCD demo. And now you can see this demo same as we did for the other platform. I can type a Q to exit after the one round. So the sine wave here. Pac-Man. The concept of driver and application allows me to run the same demo with a different LCD driver. The driver can be installed and uninstalled. So let me uninstall SSD1306. With, if I type this again, it say already installed. But if I SSD1306 with parameter called U, it will uninstall. Let's compare the memory usage. So chip info. We have the free memory is 285952. LCD demo will fail because the driver not installed. Now I install driver SSD1306. The driver installed, chip info. Now the free memory is 284800, which we have allocated some memory. Let me uninstall again. SSD1306. Uninstalled, chip info. You see all the memory are freed, and at this time LCD demo will not work.